Good afternoon, dear colleagues. The general was saying to the newcomers from marinas, he said 1 of 10,000 cases the parachute will not operate. And you're just here, just 200 people. Don't be afraid of statistics. Let's look at the statistical data to have a picture. Of course, statistics is very important. It allows us to develop business solutions, to create regulatory instruments. RIPE NCC presents to all of us an enormous measurement platform, which is a combination of RIPE Atlas and RIS. And most of statistics, which is based on these two sources, is represented at the RIPE stat in all different sorts of types and formats. You can use it, I think all of you probably is using it, and of course all the data are publicly available. First of all, I'd like to talk in my presentation about the comparison within the ENOG region with NCC region. Therefore, we decided to formalize the list of countries that refer to ENOG region. It's, of course, this is still in the process. The work is still in the process, but first of all, these are CIS countries. In the middle, you can see CIS, Baltic countries, and following the UN classification, these are the countries which belong to Eastern Europe. It's a huge region. That's more than 22.327 million of square kilometers, and this is 68% of RIPE NCC region. The population of ENOG region takes third of the RIPE NCC region, which is 1.1 billion, and the population of the ENOG region is 383 million. Here you can see the breakdown based on the countries, and of course, naturally, the biggest number of LARs are located in Poland, Ukraine, and Russian Federation. In total, there are 5,990 LLRs, which is a quite significant amount. Registration data. This graph is self-explanatory, and we can see that the interest to the rollout of IPv6 started to grow rapidly, starting since 2010, and IPv4 at the same time is losing its position. And if we could optimistically kind of outlook for this graph for a couple of screens, extend to a couple of screens, of course, I think that the interest towards IPv4, IPv6 will be equal. These are resources available for IPv4. And in 2005 it was 29%, in 2010 33%, in 2005 37%, so you can see it's about 1/3 of the total amount, and this figure doesn't change a lot. It's been calculated with the proportion of the population in the ENOG region and RIPE NCC region. With regards to the IPv6, we can see quite rapid increase starting since 2010. There is a kind of almost an angle there, a significant difference you can see based on the years and in percentages. ENOG region is of course not that fast. These are registered as, let's say, half of those for the last 10 years. And this picture shows the breakdown based on the countries. Dark gray, this is IPv4, and blue IPv6, and green, these are AS. Again, same 4 countries: Poland, Romania, Russia, and Ukraine. Routing data. This is actually the same illustration. It's very similar with the previous graphs I showed a minute ago. They show the same trend. The only thing is that the rollout of IPv6 is a little bit slower than interested towards it, but nevertheless there is a trend, and you can see growing attempts for introducing IPv6. With regards to the IPv4 prefixes, it's quite an interesting picture. Starting from 2013, for some reason a kind of stagnation happened with regards to IPv4 as to the routing of the IPv4 prefixes. I don't know how it can be explained. Maybe it can be connected with the political situation, at least in 2 countries of those out of those 4 countries. And with regards to IPv6, of course, again, you can see at the previous graph you could have seen the number of selected prefixes was increased on 100%, even 200%, and this is the picture about their use, which says that Western Europe started to invest significantly into IPv6, to invest into future, the tendency for abandoning IPv4. At the same time, you can see how this shelf, which shows that the speed of development of IPv6 slowed down in the in the ENOG region. Maybe traditionally ENOG countries prefer to to live the current moment without proper thinking what's going to happen in a couple of times. And I think in a couple of times IPv4 would be rather a headache rather than something else. This is another breakdown on percentages. This picture shows this table, let's say, is based on the work of Geoff Houston, who used Google Ads in his work for collecting statistical data to the use of IPv6 based on different countries. So he used Google Ads, and he was looking from which addresses it was used. The first column indicates how many percent Google Ads were requested in this country based on the protocol IPv6. The next column shows the privilege given to protocol IPv6 in comparison with the protocol IPv4. As to the RIPE and CC region, the median of those figures, IPv6 capability, it equals to 0.03%, and ENOG region 0.1%, which is higher. It's higher than an average data. And this is for preferences. The number of routed ASNs, it completely kind of repeats the routing of IPv6 prefixes. You can see again that shelf, that kind of equal line. So whereas there was a growth before that, now it's stagnant and stable. On this picture you can see the correlation between the population and autonomous systems. You can see that there is a drop, quite equal drop for RIPE and CC region and the ENOG region, and maybe it suggests that internet enters our life wider and wider. And RIPE Atlas measurements. In this section I'd like to talk about one interesting and useful tool created by my colleague Emil Aben. He called this instrument XP Country Jedi. Maybe it's a funny, stupid name, but that's what we have. So why would you use this tool? Why would you need this tool? It helps to, it's necessary for operators to be able to evaluate the amount of traffics and paths routes is being kind of is leaked from outside the country, which means how a local traffic could stay local. And whereas we talk here, I will talk a little bit further on about the methodology. Svetlana mentioned a little bit about the results previously, but I didn't talk about methodology. So as far as we talk now about statistics, I should mention the methodology as well. So how it happens, how do we collect the data and come to the outcomes? First of all, the list of all Atlas probes should be created. That are with reference to the country under measurement, and if, for example, you would use all the probes, then the result could be enormous. It could cost you a huge amount of credit, and it would create a significant load on the infrastructure, and in general would create a kind of surplus which we don't need. On the other hand, if you would use all probes, and very often, in many cases, in the majority of the countries, taking into account the distribution of probes geographically, for example, you can see in Russia it's all a little bit shifted towards west, then there are going to be deviations in the measurements. Therefore, it's necessary to have a creative approach towards the selections of probes, like based on the autonomous systems, or you should select a number, like randomly select number of probes, and then to start the measurements. In ideal situation, of course, it would be great to know the specific build-up in this country, and then you can get most accurate result, most accurate data. After that, you deploy trace route from each probe to the from one probe to the other one, and then based on these measurements data, we build a matrix. Based on this matrix, you can identify the route of traffic, and if we, for example, know which prefixes are used in different exchanges, then we can trace different paths through those exchanges and how many paths exist in them. Unfortunately, we have here two examples. In Ukraine and Romania, it's senseless to do it in the Russian Federation because they have a huge, enormous amount of probes, and I had no time to prepare this information for Russian Federation. But and regrettably, Emil, he is involved into the experiments, into this testing, and he used only Imperial DB, and it's only represented by AUX. Other exchanges are not represented there. Therefore, it's very difficult to say something, to come to any conclusions, but based on this one exchange, and I think our figures are similar to figures presented by Svetlana, it means that about 40% of traffic goes through UAAX. How it looks on the picture, you saw it yesterday. You can see there is lots of traffic going beyond the boundaries of the country. It goes to Moscow, to Western Europe, and similar situation can be mentioned with regards to the IPv6. Romania, for example, looks very nice. All local traffic stays local. Probably they did a good job, but the situation with the IPv6 is not that good. Next topic I'd like to talk about, this is key route. This is my final topic. You probably know that RIPE NCC started to enhance key route, and for the recent year rolled out 6 6 instances key route within the ENOG countries in Prague, in Riga, in CNA, Kazakhstan, in St. Petersburg, Yerevan, and Warsaw. And we performed certain measurements to have a look how it looks statistically wise. We built such a kind of visual distribution. In red color you can see this is the distribution for the previous year, how it looked like a year ago, about a year ago, let's say preliminary in September. Green color illustrates the current situation, and you can see that the distribution is more or less equal, even, and that the shape is very similar, and the width of the distribution is so it has been done properly. But the peak of this distribution was shifted towards the drop of RTT, decrease of RTT, and as you can see that the new the new index of RTT is decreased from 50 to 20 milliseconds, even more than twice. For IPv6 it's even better, taking into account this peak and this peak, this top data. You can see there is a 3 times increase in 3 times, so the job was done very well, and it helped to improve the situation. That's it from my side. That was a very brief presentation. Your questions, please. Any questions to Viktor? It's more as a clarification. On your graph there was a kind of even line of road back in 2013, and you said that you don't know what were the results. I think it was connected that at the end of 2012 they stopped to issue IP addresses. But it's not. It was stopped not only being issued to ENOG region, then we would see it for the whole region. But you also showed statistics on RIPE-SCC, but this line was for ENOG region. Everywhere it was kind of stopped everywhere. As an example, RIPE and CC, you can see the growth. Yeah, you can see the growth. For ENOG, there is a shelf here. There is a kind of even line. Maybe it's connected with the fact that small networks are issuing this is for LIRs. Maybe, yeah, could have been. This is something to think about. Yes. Any other questions? Thank you, Viktor.